Hi everyone, my name is Bashar Namar, and today I'm going to be talking about data lakes and data warehouses. Now, in the realm of data management and analytics, data lakes and data warehouses have emerged as pivotal solutions for organizations looking to control their data. Because as we know, any organization or company has data that needs to be stored somewhere and ways that we can retrieve this data and use it again. Both serve as centralized repositories for large volumes of data, yet they differ fundamentally in their design, purpose, and implementation. As we're going to see later, data lakes and data warehouses differ in the ways that this data is stored, this data is retrieved, and what data they can store. Now, understanding these differences is crucial for businesses aiming to leverage their data for competitive advantage. Because as we know, these companies use this data to know more about their competitors, know more about themselves, and most importantly, know more about their customers so they can know what is needed, um, for example, in their business and how they can improve their business to get more sales, for example. Now, data lakes and data warehouses address different needs within the data lifecycle, offering unique benefits and use cases that cater to various organizational requirements. This introduction delves into the core characteristics of data lakes and data warehouses, highlighting their roles in modern data architecture. Now, let's start with data lakes. A data lake is a central location that holds large amount of data in its native raw format. Compared to a higher called data warehouse, which stores data in files or four folders, a data lake uses a flat architecture and object storage to store the data. Object storage stores data with metadata tags and a unique identifier, which makes it easier to locate and retrieve data across regions and improves performance. By leveraging inexpensive object storage and open formats, data lakes enable many applications to take advantage of the data. So what this tells us basically that data lakes have an easier way of an easier access. So we can access this data in the data lakes much more easier than, let's say, a data warehouses. So yeah. Now, data lakes were developed in response to the limitations of data warehouses. While data warehouses provide businesses with highly performant and scalable analytics, they are expensive and proprietary and can't handle the modern use cases most companies are looking to address. Data lakes are often used to consolidate all of an organization's data in a single central location where it can be saved as is, without the need to impose a schema, a formal structure for how the data is organized, upfront like a data warehouse does. Data in all stages of the refinement process can be stored in a data lake. Raw data can be ingested and stored right alongside an organization's structured, tailored data sources like database tables, as well as intermediate data tables generated in the process of refining raw data. Unlike most bases and warehouses, data lakes can process all data types, including unstructured and semi-structured data like images, video, audio, and documents, which are critical for today's machines learning and advanced analytics use cases. And that's what most special about data lakes is that we can store anything in these lakes. So basically, we can store videos, images, text, documents, and all of that can be stored and retrieved without being changed, which means we can use it for later on and we can use it most recently in machine learning, generating all these images, videos, or whatever. Like these are being retrieved from data lakes. Here is a small diagram to showcase what I'm talking about, like the structure, semi-structured, and unstructured data enters this data lake, and then it can be used later for like business analytics, I think, streaming analytics, data science, and machine learning. Now, let's talk about data lake advantages. And in modern data architectures, data lake offers several compelling advantages. Open format. Data lakes use open formats, which help users avoid lock-in to proprietary systems like traditional data warehouses. So basically, the data is not really locked away in a place that makes it hard to retrieve this data. Data can be retrieved easily. Durability and cost effectiveness. Data lakes are durable and low cost due to their scalability and use of object storage. Advanced analytics and machine learning. They support advanced analytics and machine learning, particularly on unstructured data, which is a strategic priority for many enterprises. Versatile data ingestion. Data lakes can ingest raw data in a variety of formats, structured, unstructured, semi-structured, offering greater flexibility and functionality for data storage. And this is the most important thing about data lakes, as I said before. Now let's see like a few use cases for data lakes. Power, data science, and machine learning. Data lakes allow you to transform raw data into structured data that is ready for SQL analytics, data science, and machine learning with low latency. Raw data can be retained indefinitely at low cost for future use in machine learning and analytics. So yeah, easy to retrieve and not costly. And the data isn't changed. It's saved as it is. And like who doesn't want that? That's why companies like to use data lakes a lot. Centralize, consolidate, and catalog your data. A centralized data lake eliminates problems with data silos like data duplication, multiple security policies, and difficulty with collaboration, offering downstream users a single place to look for all sources of data. So data is stored in one place, which makes it less confusing to retrieve this data and makes like the bumping of data into each other less often. Quickly and seamlessly integrate diverse data sources and formats. Any and all data types can be collected and retained indefinitely in a data lake, including batch and streaming data, video, image, binary files, and more. And since the data lake provides a landing zone for new data, it is always up to date. Democratize your data by offering users self-service tools. Data lakes are incredibly flexible, enabling users with completely different skills, tools, and languages to perform different analytic tasks all at once. So, what this basically tells us is that data lakes are more accessible than other data storage forms. Like you don't need to be a professional at data analysis or database systems to know how to use these data lakes. Data lakes challenges. Despite their pros, many of their promises of data lakes have not been realized due to the lack of some critical features. No support for transactions, no enforcement of data quality or governance, and poor performance optimizations. As a result, most of the data lakes in the enterprises have become data swamps. Reliability issues. This is the first disadvantage of data lakes. Data lakes can suffer from data reliability issues, making it difficult for data scientists and analysts to reason about the data. These issues can stem from difficulty combining batch and streaming data corruption, and other factors. Now, we said that data lakes can take data in raw data form, so basically anything can enter the storage, structured, semi-structured, or not structured data. And this causes a problem that there can be too much data in one place, and it makes it hard to retrieve a specific type of data that we need. Slow performance. As the size of the data in the data lake increases, the performance of digital query engines typically slows down. Some of the bottlenecks include metadata management, improper data partitioning, and others. Lack of security features. Data lakes are hard to properly secure and govern due to the lack of visibility and ability to delete or update data. These limitations make it very difficult to meet the requirements of regulatory bodies. So obviously it's not a great thing to not be able to delete or update your data, which can cause major security features. Yeah. Data warehouses. This is the second type of data storage that we're going to talk about today, and the one that we're going to compare with the data lake. A data warehouse is a digital storage system that connects and harmonizes large amounts of data from many different sources. Its purpose is to feed business intelligence, reporting and analytics, and support regulatory requirements, so companies can turn their data into insight and make smart data-driven decisions. Data warehouses store current and historical data in one place and act as a single source of truth for an organization. Data flows into a data warehouse from operational systems like ERP, enterprise resource planning, and CRM, customer relationship management. And as derived from their name, enterprise resource planning is basically more business side, like the whole company itself. And customer relationship management focuses on the customer side of this data. Anyways, databases and external sources such as partner systems, Internet of Things devices, weather apps, and social media, usually on a regular cadence. The emergence of cloud computing has caused a shift in the landscape in recent years. Data storage locations have moved away from traditional on-premise infrastructure to multiple locations, including on-premise, private cloud, and public cloud. Now, as we all know, and as we have all gone through it, multiple years ago, we used to store our data or whatever we needed, files, folders, games, movies, on small hard disks or small flash drives. But now with the ability of cloud, we can just store this data in a place that is not even physical. And that makes it easier for us because we don't need to buy hardware, we just buy the software of it. And we can save all of what we want in one place that is usually unlimited, but comes with a cost factor that we'll talk about later on. Modern data warehouses are designed to handle both structured and unstructured data like videos, image files, and sensor data. Some leverage integrated analytics and in-memory database technology, which holds the data set in a computer memory rather than in disk storage. To provide real-time access to trusted data and drive confident decision-making without data warehousing, it's very difficult to combine data from heterogeneous sources, ensure it's in the right format for analytics, and get both a current and a long-range view of data over time. Here's a small diagram showcasing data warehouses. These are the data warehouse sources. They go into this data warehouse, and then we get analysis, reporting, data mining, or whatever we want to use out of this data warehouse. Benefits of data warehouses work. I forgot to put up here, small mistake. A well-designed data warehouse is the foundation for any successful business intelligence or analytics program. Its main job is to power the reports, dashboards, and analytical tools that have become indispensable to businesses today. A data warehouse provides the information for your data-driven decisions and helps you make the right call on everything from new product development to inventory levels. There are many benefits of data warehouses. Here are just a few. Better business analytics. With data warehousing, decision makers have access to data from multiple sources and no longer have to make decisions based on incomplete information. Yeah, so that's very self-explanatory. Faster queries. Data warehouses are built specifically for fast data retrieval and analysis. With a data warehouse, you can very rapidly query large amounts of consolidated data with little to no support from IT. Now, as we talked, due to the way that data lakes get their data, basically in any form, that makes it a little bit slower to retrieve this data or save it or whatever. But because the data warehouse only takes structured data, so it makes it easier or makes it quicker, not easier. Improve data quality. Before being loaded into the data warehouse, data cleansing cases are created by the system and entered in a work list for further processing, ensuring data is transformed into a consistent format to support analytics and decisions based on a high quality accurate data. Historical insight. By storing rich historical data, a data warehouse lets decision makers learn from past trends and challenges, make predictions, and drive continuous business improvement. Data warehouse challenges. Additional reporting. Additional work is required for using data warehouses because data stored in a warehouse is structured, meaning that to create reports, you must design and maintain predefined queries and data models. This is time-consuming and delays in generating essential reports. So basically what this means is that we cannot just throw the data into the data warehouse. No, we need to structure it in a way that whatever way the company structures its data or whatever way the database, let's say, department uses its data, we need to structure it in that way so we can query it into the data warehouse rather than just putting it anyways. Inflexibility and homogenization of data. Data warehouses depend on structured data, which is organized into predefined formats. This can be a problem when handling unstructured data, such as social media posts or multimedia content. Unstructured data doesn't fit well within the structured framework of data warehouse. If the organization deals with a lot of unstructured data, it will face problems in integrating data effectively. Yeah, so as we said, because data lakes can take any form of data, so it makes it a little more accessible for companies or users or whatever. Ownership concerns. Data warehousing systems often involve multiple departments and teams. This can lead to ownership issues determining who's responsible for various aspects of data warehouse, including data governance and quality, and this can become a complex task. Demands for a large amount of resources. Implementing and maintaining a data warehouse can be resource intensive. The organization has to invest in hardware, software, and skilled personnel to set up and manage the system. This upfront investment can be substantial and may not be feasible for small or resource-constrained organizations. The ongoing cost of maintaining a data warehouse can also add up over time, so it's more costly than data lakes. Let's see an overview of data warehouses and data lakes. The data type, data lake states any data type, while a data warehouse only takes structured. Data processing, it supports batch, real-time, and streaming data processing, so process anything, but data warehouses focuses on batch processing and some like small real-time capabilities. Data storage costs, it's lower than a data warehouse. It's higher due to the need for more expensive optimized storage, since we need to structure the data again. User accessibility is more accessible for data scientists who can work with raw data, more accessible for business users and analysts. So data warehouses are usually used by more professional people rather than like not really casual users, let's say. Passive implementation. Lower initial cost, but can grow with complexity. Higher initial setup and maintenance costs. Now, let's take a few examples of data warehouses or lakes or whatever. And we're going to start with Google BigQuery. Google BigQuery is a fully managed serviceless and highly scalable data warehouse designed to enable fast SQL queries and analytics on large datasets. It's part of the Google Cloud Platform, GCP, and is widely used for analyzing big data thanks to its powerful capabilities and ease of use. Serviceless architecture. These are the features of Google BigQuery and why people would use it and why people would not. It honestly depends on each user's need, because later we're going to talk about Snowflake and then about Microsoft's, which is called the Azure Synapse Analytics. So yeah, let's get back to where we were. Serviceless architecture. No need to manage infrastructure. Google handles resource allocation, scaling, and optimization. Massively parallel processing enables rapid execution of complex queries by distributing the workload across many machines. Real-time analytics supports real-time data streaming and analysis, allowing for near instantaneous insights. Integration, seamless integration with other Google Cloud services, machine learning tools, and third-party tools. As we know, Google is a mega huge company. So obviously this is well integrated into their let's say ecosystem. Pay-as-you-go pricing. Charges based on the amount of data processed with options for flat rate pricing. So the more data that we need, the more data that we're gonna process, the more we're gonna have to pay. And this is an efficient way rather than paying at one time, which can be way too little for some, or it can be way too much for some others. Anyways, Snowflake. Snowflake is a cloud-based data warehousing platform that allows organizations to store and manage and analyze large amounts of data. It's designed to handle both structured and semi-structured data and is known for its scalability, flexibility, and performance. Scalability. Easily scale computer resources up or down for efficient management of large datasets and workloads. Separation of storage and compute, scale storage and compute independently, paying only for what you use. Data sharing, securely share data across organizations or departments without moving or copying it. Support for various data types, handle structured and semi-structured data formats like JSON, Avro, Parquet, and XML. Zero management, fully managed service with automatic scaling, maintenance, and optimization. And the last one, or the last thing in this video, Microsoft Azure Synapse Analytics. Microsoft Azure Synapse Analytics is a cloud-based analytics service provided by Microsoft as part of the Azure ecosystem. It is designed to combine big data and data warehousing capabilities into a single unified platform. This service allows organizations to analyze vast amounts of data run complex queries, and gain insights to drive business decisions. Unified Analytics combines data warehousing and big data analytics in one platform, enabling seamless querying. Data integration offers tool for orchestrating ETL processes, supporting various data sources for easy data movement. Synapse Studio, a web-based IDE that lets data professionals handle everything from ingestion to visualization in one place, which makes it easier for database users or developers to use the system. Multiple query engines supports SQL for structured data and Apache Spark for big data, covering diverse analytic needs. And the last thing, security and compliance provides robust security features and meets industry compliance standards to protect data. And that was it. I hope it wasn't too much. I hope everything was clear and the whole PDF was clear and helpful. And yeah, let me just turn off the screen sharing. Yeah, this was very fun to make, and I hope that anyone who watches this video learns and finds it helpful. Thank you.